Hello, and welcome to this lesson on Group 7, the halogens. In today's lesson, we will understand what the halogens are and where we find them on the periodic table. Then we will learn about the molecular structure of halogens and explore their outer shell electron configurations. So far, we've discussed electron configurations and how the periodic table is organized. You're already familiar with concepts like electron shells and how elements are grouped based on their atomic structure and properties. Building on this foundation, today's lesson will advance our understanding by examining the specific characteristics of the halogens. By understanding their molecular structure and electron configurations, we can gain insights into their reactivity and behavior in chemical reactions. This deeper knowledge helps us appreciate how elements in Group 7 fit into the broader patterns observed in the periodic table. What are halogens? The halogens are a group of elements found in Group 7 of the periodic table. Examples of these elements are fluorine, chlorine, bromine, and iodine. All of these elements are non-metals. The name halogen comes from Greek words meaning salt former, because they often form salts when they react with metals. One characteristic feature of the halogens is that they all have 7 electrons in their outer shell. To achieve a full outer shell, which consists of 8 electrons, they need to gain just 1 more electron. This makes the halogens highly reactive, as they readily seek to acquire this additional electron to achieve a stable, noble gas electron configuration. Having the same number of outer shell electrons gives the halogens similar chemical behaviors. Halogens exist as diatomic molecules, meaning they always pair up to form molecules consisting of 2 atoms of the same element. Hence, chlorine as Cl2, fluorine exists as F2, bromine as Br2, and iodine as I2. This diatomic nature is a result of their high reactivity. In order to gain 1 electron to complete their outer shell, each halogen atom shares 1 electron with another atom of the same element, thus creating a bond and a diatomic molecule. We will delve deeper into electron sharing and bonding in a later unit. Despite being in different periods, or rows, of the periodic table, they exhibit similar properties because the number of electrons in the outermost shell is the same. In summary, the halogens are a series of highly reactive nonmetals with 7 electrons in their outer shell. They exist as diatomic molecules in nature and form similar chemical bonds due to their electron configurations. Understanding the electron configuration and molecular structure provides insight into their reactivity and properties. In today's lesson, we delved into the properties of the halogens, which are located in Group 7 of the periodic table. We identified the halogens as a group of nonmetals that include fluorine, chlorine, bromine, and iodine. These elements share similar chemical properties due to their 7 electrons in the outer shell, which makes them highly reactive. Then, we examined the molecular structure of halogens, noting that they typically exist as diatomic molecules, meaning each molecule is composed of 2 atoms. Additionally, we explored the outer shell electron configuration of the halogens. Each halogen has 7 electrons in its outermost shell. This configuration explains their tendency to gain 1 electron in chemical reactions, resulting in the formation of negative ions.